Beats. The phenomenon of periodic variation of intensity of sound when two sound waves of slightly different frequency but same amplitude moving in the same direction interfere is called beats. Let us consider two harmonic sound waves of n frequency omega 1 and omega 2 with slightly different frequency having same amplitude and same initial phase pi by 2 moves along x-axis. The expression for waves are given as s1 equal to a sine kx minus omega t plus omega 1 t plus pi by 2 equation 1 and s2 a sine kx minus omega 2 t plus pi by 2 equation 2. Taking x equal to 0, the equation becomes s1 equal to a sine pi by 2 minus omega 1 t equals to a cos omega 1 t equation 3 and s2 a sin pi by 2 minus omega 2 t a cos omega 2 t equation 4. The resultant displacement of wave is s equal to s1 plus s2 a cos omega 1 into t plus a cos omega 2 t or a into under bracket 2 cos omega 1 plus omega 2 by 2 into t into cos omega 1 minus omega 2 by 2 into t equals to 2a cos omega 1 minus omega 2 by 2 into t cos omega 1 plus omega 2 by 2 into t equals to 2a cos omega 1 omega t omega b into t into cos omega at, where omega b omega 1 minus omega 2 by 2 and omega a equal to omega 1 plus omega 2 by 2. Now if assume mode of omega 1 minus omega 2 very less than omega 1, then omega 1 plus omega 2 is very greater than mode of omega 1 minus omega 2, or omega 1 plus omega 2 by 2 is very greater than mode of omega 1 minus omega 2 by 2, or omega a is very greater than omega b. This means that result resultant wave is oscillating with the average angular frequency omega a. Thus we can write equation 5 as s equal to 2a cos omega bt into cos omega at equals to cap a into cos omega a t. Question b, where a equal to 2a cos omega b into t represents the amplitude of the resulting wave. This shows that amplitude varies with time, unlike being constant for pure harmonic waves. Note that intensity I proportional to amplitude square. First, the amplitude will be maximum if cos omega b into t equal to plus minus 1, or omega b into t equals to n pi, where n equal to 0, 1, 2, 2 dash dash dash. This implies omega 1 minus omega 2 by 2 into t equals to n pi. This implies t equals to 2n into pi by omega 1 minus omega 2 equals to 2n into 2 pi by 2 pi into nu1 minus nu2 equals to n by nu1 minus nu2. Thus amplitude, hence intensity is maximum at time t equal to 0, 1 by nu1 minus nu2, 2 by nu1 minus nu2 dash dash dash. Hence time interval of maximum intensity equals to 1 by nu1 minus nu2. Hence frequency of maximum intensity equals to 1 by nu1 minus nu2 equals to nu1 minus nu2 equals to bit frequency. Second, the amplitude will be minimum if cos omega b into t equal to 0, omega b t equals to 2n plus 1 into pi by 2, n equal to 0, 1, 2. This implies t equals to 2n plus 1 by omega b into pi by 2 equals to 2n plus 1 into pi by 2 pi into nu1 minus nu2 by 2 into 2. This implies t equals to 2n plus 1 into 2 into nu1 minus nu2. Thus intensity is maximum at t equals to 1 by 2 into nu1 minus nu2, 3 by 2 into nu1 minus nu2, 5 by 2 into nu1 minus nu2 dash dash dash. Time interval of minimum intensity 5 by 2 into nu1 minus nu2 minus 3 by 2 into nu1 minus nu2 equals to 2 by 2 into nu1 minus nu2 equals to 1 by nu1 minus nu2. Time interval of maximum intensity equals to bit frequency.